Hey students, so this is a quick revision to number system. You often wonder where number system is used in computer. So for now, we can say that a computer only understands numbers, and with these numbers it gets our message and understands what we are trying to say. Now, a number system, as we know, is divided into four parts. The first part is binary number system. The second part is decimal number system. Third part is octal number system, whereas the fourth part is hexadecimal number system. Now, this is a table which is telling us about the type, base and range of number system. The first number system that we can see here is binary. The base of binary number system is 2, which means it only has two digits, 0 and 1. So we can write a binary number with the combination of zeros and ones. Octal number system has the base 8, which means it ranges from 0 to 7, and we can make a combination of numbers from 0 to 7 in order to write an octal number. Then decimal number has base 10, which means it ranges from 0 to 9, which means the combination of numbers from 0 to 9, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, can be used in order to write a decimal number. Then last is hexadecimal number, which has base 16, which means we can have a total of 16 digits to write a hexadecimal number, or a combination of 16 digits ranging from 0 to 15 to make a hexadecimal number. Now, here let us study a little bit more about hexadecimal number. Now we have a number 1512 written here with base 16, which means it is a hexadecimal number. Now what if it's 15 and 12? So here we are left with a confusion that 1512 is single digit 1512, or is it 15 and 12? Because we know numbers from 0 to 15 can be used in order to write a hexadecimal number. So let us move forward in order to solve this confusion. Now here we have a conversion table in which we have decimal numbers at the left hand side and hexadecimal numbers at the right hand side. So we can see 0 as a decimal number is written as 0 only in hexadecimal. The equivalent hexadecimal code for 1 is 1, 2 is 2, 3 is 3, and so on till 9. Now after 9 you can see we have a highlighted part of numbers ranging from 10 to 15. Now 10 in hexadecimal is written as A, 11 is written as B, 12 is written as C, 13 is written as D, 14 is written as E, and 15 is written as F. Now let us see how it helps in writing a hexadecimal number. Now here we have the table and the number is 1512. Now as I told you, if it is 1512, it will be considered as single digit 1, 5, 1 and 2. And in case it is 15 and 12, it won't be written as 15 and 12. Rather, we'll be seeing the hexadecimal equivalent of 15 here in the table, that is F, and for 12 is C. So the number will be FC base 16. So if we find FC base 16 written there, it means it's 15 and 12. And if we have 1512 written there, it means these are the single digits. Now, converting to a decimal number, what are we supposed to do? Now, always remember, we have to multiply with the base. Now, what does this mean? Now here, as you can see, we have a decimal number. Now to convert into a decimal number, what are we supposed to do? Now if we have a binary number and we are supposed to convert it into a decimal number, the only thing that we are going to do is to multiply it with 2 raised to the power n, which refers to the number of digits there. Then from octal to decimal, as we know, the base of an octal number is 8, so we'll be multiplying an octal number with 8 raised to the power n in order to convert it into a decimal number. Next is the hexadecimal number, and the base of an hexadecimal number is 16. So in order to convert a hexadecimal number into a decimal number, we'll be multiplying it with 16 raised to the power n. Now, let's see. Always remember, we have to remember one thing before moving forward with the conversion, that is the reverse rule. Now, what does this reverse rule mean? Like we have a number 1, 2, 3. While you are converting it into any form, you will be writing it from the last part, the right hand side, and which will be written as 3, 2, 1. Now, let's move forward. Now, 1010 base 2, which means this is a binary number, will be converted into a decimal number. Now see, in order to convert it into a decimal number, what we are going to do, we are going to reverse the number, write it as 0101, multiply it with 2 raised to the power n. Now see, 2 raised to the power 0, next is raised to the power 1, next is raised to the power 2, and next is raised to the power 3. After multiplication, we get these answers as 0, 2, 0 and 8. After adding them up, we get an answer that is 10. So we can say that 10 base 10 is the equivalent of 1010, which is a binary number. And 10 is a decimal number that we have got with the help of this conversion. Now next, we have 6AF base 16, which means it is a hexadecimal number. We've revised it right now. Now in order to convert, F is written as 15, A is written as 10, and 6 is as it is. And you can see that we have reversed the number. Now, since we are converting a hexadecimal number into a decimal number, we'll be multiplying them with 16 raised to the power 0, 1 and 2. After the conversion, we'll just multiply them, add them up, and the answer that we are going to get is 1711, that is 1711. Next is conversion from decimal number. Now, conversion from decimal number, you have to divide with the base. Now, let's see what we are supposed to do. In order to convert a number to binary from decimal, we'll be dividing it by 2 raised to the power n. Now, to convert it into an octal number, we'll be dividing it with, 8 raised to the power n. Now, to convert it into a hexadecimal number which has base 16, from decimal, we'll be dividing it with 16 raised to the power n. So here we have an example for you in which we'll be converting a decimal number to a binary number. Now reminder for you is that the base of a binary number is 2. Now let's see. Now here we've made a table for the conversion, or we can say a conversion table or a calculation table for us. The number that we'll be converting into binary is 14. Now, in order to convert 14 into a binary number, you will be dividing it with 2. Now, see, 2 sevens are 14, and at the right hand side, we will be writing the remainder, and here the remainder is 0. Next, 2 3s are 6, and the remainder is 1, which we will be writing here. Now, 2 1s are 2, and the remainder will be 1 here, and we are left with the last 1, so we don't have to divide it, we can directly write it there as 1. So here we are done with the conversion. And one more thing, what you are going to do is to try these questions and write the answers in the comment box so that you people can see what are your answers, and in the end I'll check and give you the answers. And there'll be a link for the test below which you'll be giving, and it's a Google form test that you will give, and then you can tell your scores there. Okay, all the best everyone.